office hours, and you come to mind, any GSIs. Find a GSI who really does a good job teaching to you, right? That'll make a huge difference for your performance in this class, probably, right? And it won't necessarily be the GSI who's running your discussion in lab sections, right? Might be, but it might not. So go to office hours to the person who can help you out the most. And also in terms of letters, so students often want to, they want to go to med school, they want to go off to grad school, whatever it is, and they like a letter. So in this, there's a lot of students. I don't actually write letters of recommendation myself from scratch in this class. I ask you to go, if you'd like a letter, if you come in, I'll say, go to your GSI. And by your GSI, I mean any GSI in the course that you feel got to know you and can say something intelligent about your performance in the class and your attributes. Have them write the first pass of the letter. They'll send it to me, and I'll add my 2 bits and co-sign it, right? I'll mention your performance in the overall class, your grade, and all those things. And if I know you personally, I might add something else. But the main person who's writing the letters is your GSI. Get to know your GSI. He or she can write you a letter later, and also they'll help you do well in the course. Anyway, yes, so there are many resources. Let me just really quick show this to you. Many resources in this class. It's all listed on here. The Student Learning Center, the Honor Society, Society for Physics Students, on and on, Physics Scholars Program. Anyway, there's lots of resources. There are tutoring services. There are drop-ins, all these kind of things. You can find all that stuff out from, again, Claudia Trujillo in Physics Student Services can set up with that. And so that's very helpful. Okay. Good to know. Oh yeah, here's my lab policy. There's no lab, so for the first couple weeks of the class, there's no labs to avoid any. Just make sure things settle out before you start actually doing labs that actually count toward your grade. You need to show up to have your attendance taken, but the actual labs won't start until week 3. And here are the weeks where we have actual labs: 3, 5, 8, 9, 12, 13, 14. As I mentioned earlier, you have to complete at least 6 of them to pass the class, and you should pass them all. You should do them all in order to get the best grade you can in the class. Right. Anyway, here's all the policy about doing makeups for labs. It's online. You can read that from DSpace. Here's the syllabus that's on there too. At the bottom here, I've got all the times and locations as they're known for exams. So make sure there's no conflicts with labs and everything. Over here, you can see for each day. I'll mention in class what we're going to read, but you can also find that out from the syllabus. This will probably change though, because invariably I get a little out of sync. There's a lot of material in this class. I try to change my lectures based on how quickly or slowly students are picking up the information. If I get feedback from GSIs, wow, they sure didn't get that last lecture, I might go and revisit some topics, make sure it's clear. Here's the information sheet about mastering physics. So this just describes step by step how you get on there on the online homework. This is for this course in particular. It's MP as in mastering physics. My last name 74066. That's the particular course number for this class. So you can sign up. There's homework due this week, but it's not for credit. It's just to get you familiar with the system. So if your access code doesn't work and whatever, things are a disaster, you're not going to lose any points for missing your homework this week. It's just so you can see how the system works. Next week on Friday, the homework is actually for credit and counts. So, all right. Oh yeah, and students always ask. It's easier, I think, to learn the actual physics in the course than to learn how mastering physics actually works. But students will obsess about this, so I'll tell you really quick how it works. Here's the main thing to notice. You get 4 chances to get the answer right before you lose credit. So when you're entering answers into mastering physics and you have a decimal in the wrong place, or you put a W instead of an omega, or whatever it is, and you don't get any credit, that's okay. You get 4 chances. Now these aren't guesses. Do not treat these as guesses. Students will say guess. Okay, now I'll solve the problem, and then they go and answer, and then they put the omega in for W, and then they send me these nasty emails. I say no. The way to handle it is to treat every time is like your last chance, right? And so write out your solutions. Get your answer. Be able to defend your answer before you enter that number into the little box, the symbolic answer number, whatever it is. And there's all these other things. It turns out that there's a marginal amount of extra credit you get by getting it right the first time instead of later, but you don't get any points docked. You'll still get 100% if you get wrong, correct. If you do that, you'll still get full credit. But I think you get a little extra credit. There are hints on mastering physics, and you can open those hints. You're not penalized for opening them. But then if they ask you a question in the hint, you have to answer the question. If you get that wrong, it can cost you. So the thing is, here's the thing. I set this up to encourage you to do as much as you can on your own, but to not be penalized very much by taking advantage of the extra information. And the way I would do it if I were taking this class is I'd write my answers out longhand and have it figured out before I enter anything. And if I get stuck, I'm getting to the next part of I'm going to spend more time on this in 1 minute. So let me just do a little more business. Oh yeah, so here's a piece of business. So my first time teaching this class, a news crew came in from some local news station, I forget which one, and they're filming. I'm thinking, now this is the respect, right? This is why I'm here at Berkeley. And I told my parents, and so I go, and so I turn on the TV. Actually, I don't have TV in my house, but one of the people who works here watches TV and goes, I taped it for you, so I'm watching. And it's not about great teaching a cow, right? It was a segment about stress on campus, and here I am, and they got me gesticulating, and all this stuff, and then they switch over to some depressed student, whatever. So look. This is a big class too. So the main reason to show this is there's 350 of you out here, right? There are services on campus. I should zoom out. This is online. You can see it. And you already know this anyway, probably, but just so everybody's on the same page. There are great services on campus for students who are experiencing stress, and it's worth knowing. I'll tell you. Don't tell anybody. But when I was your age, I benefited from these services. I was at UC Santa Cruz, my alma mater, UC Santa Cruz, and I was very happy to be there. A lot of fun, mostly fun, but once in a while I was stressed out. I took too many classes one semester. So anyway, so you go in and they have drop-in services and they have one-on-one counseling. It's a great thing. So it's just good to know that there's health services for mental health as well as your physical health. You break your arm, go to Tang. Well, if you're stressed out, you can go there as well. If it's not getting better on its own, and if it's good to know. Berkeley's a fun place, but some students can be overwhelming for some students. I guess there's not many freshmen in the room, so you guys probably know the drill. But anyway, so just be aware. Another thing, let's see. So now let's start segueing into the part of the class. Let's see, make sure I'm done with all the business stuff. Business. Already dropped deadline. I mentioned that. Homework, lab policy. Yep. Experiment. No guessing. All right. Student services. Oh, a note taker. So I believe there's a note taker. Is there an official note taker in this class? Can you raise your hand? I'm not seeing it. Also, when you raise your hand in here, it's got to be like Run DMC. Okay. I can't. There's a lot. That's a band. A long time ago. I can't see a note taker. So I think there's going to be a note taker in this class, and you can buy the notes. You're not required to. It's not part of the class per se, but I think there'll be a note taker and be made available. I'm not sure actually. I didn't see anybody raise their hand just now. But here's my advice about notes. When I was your age, I would start taking notes in the beginning of the semester, but pretty quickly I realized that I was paying more attention to writing stuff down than what the professor was saying. I was better off not taking notes or just writing down occasional notes. Like, wow, that equation is really important. I'm going to jot that down, right? But I don't try to write down. I'm a fast talker, in case you haven't noticed already. So it's tough to get everything I say down, but you might want to write down the gist of what I said over the last 5 minutes or some important equations. The one reason why I use a Blackboard in lecture instead of using using PowerPoint slides is it forces me to keep the material flowing at a rate that I can actually write it down, right? And that's good for you because that means that I'm not going to zoom through things, hopefully, right? It also means that I can make mistakes and you'll see me recover, and that's also a benefit. Even though some students freak out in this class when they see me make mistakes, they think, if you can't get it right, I'm doomed, right? There's no way I can, and that's not the way it works. Physics is all about recovering. It's about partial credit. It's not about getting everything exactly right the first time you write it down. So it's okay if I make an occasional mistake, if I do say so. So homework is a predictor. Why should you do your homework? Here's the reason to do the homework. Yeah, it's 10% of your grade, but that's not why. The reason to do it is that there's a strong correlation. Between so I'm showing you some data. I got homework performance on the horizontal axis, and I've got. I should zoom out a little bit, I guess. Sorry. And I've got. What is it? Yeah, people are. Yeah. This is a final grade in the class, and what do you know? It's just a positive correlation. But it's not 100% correlation. There are still students who, like here's a student who did 100%, 100+% on the homework, right? But they're down here at like 60 some odd. This is maybe it's passing quality, but it's not an A, right? So So doing the homework doesn't guarantee you an A in the class, or even passing doesn't even guarantee you passing the class. Although it almost does. Very seldom do students do all the homework and not pass. That's rare, very rare. That's a special effort to do all the homework and not pass the class. Special. Although there are certain students who phone it in, there's lots of ways of cheating on the homework. And I can't check and see if you're cheating, except when you do the midterm. That's how I check. The midterm is how I check whether you're actually doing the homework, right? Or whether you just had friends tell you the answers, you Googled the answers. Yeah, you could probably Google them. You guys are all smart enough to know how to do that, but don't do it. If you're smart enough to do that, you're smart enough to know it's not going to help you out. The way to succeed in this class is to really do the homework, and to not get stuck too long on one problem. When you work on a problem, you get stuck somewhere. It's good to beat your head on it for a few minutes, 5 minutes. Okay, go look up, revisit the book, see if you can find a solution to what's causing you trouble. And then after 15 minutes, okay, or 20 minutes, okay, mark it and come back to it later. Talk to a friend who's in the class. Say, hey, did you have trouble with problem 3B? Yeah, me too. So, use your fellow classmates as a resource. Learn from each other and benefit your score in the class. You learn material. It's also more fun. Yeah. That's a good question about mastering physics. The question is, can you fast forward to the questions? I think you're not usually able to advance through different parts of a given question, because often the previous answer informs you about the next part. So I don't think it's usually the case you can jump around within a question, but I think you can choose which question to do first, second, and third. So you can say, okay, I'm not making progress on this problem. Let's go and look at this other one. And if you're writing out your homework as you go, then before you enter your answers, I guess that's sort of, no. So before you write out before you enter your answers. If in fact you can't look at the next part of the question before you enter your answer within a problem, then it suggests yes that you have to enter your answer in order to find out what you have to ask. So okay, that will happen sometimes. But in terms of which question you do in what order, yeah, I think you can do them anywhere you want. Yeah, it's a good question. And on tests, I strongly advise you to get a feel for the overall exam before you sink an entire hour into problem 1A, right? I mean, make sure you know where the easy and the hard problems are, and don't get stuck anywhere for too long, right? But that's for test taking strategy. We'll get to that later in the semester. We'll get to that. So yeah, it's a good question. Ask me questions. It's good. Homework's a breaker. So do the homework is the point of this graph. The point of this graph is going to surprise many of you, I think. Hopefully not horrifying. So here's a graph of midterm 1 versus total performance in the class. Once again, strong positive correlation. Students who do really well in the first midterm tend to do really well in the whole class. Look at these data points down here in yellow, though. This sad sack here, oh, this unhappy soul, who did really well. Oh, wow. Kicking booty up here on the first midterm, right? But then, not quite the 8 performance maybe on the overall class. Who are these people? Who are these people marked in yellow? What distinguishes them from the rest? And actually, there's other yellow points up here. I just didn't bother to mark them. Just to make that clear. But what's special about the yellow points down here? That's right. But did anybody know? You know. They had AP Physics. So if you take AP Physics, that's a good thing. Good for you. It helps you in this class. It makes you a better person. But it does help you in the class. But it won't help you if you abuse it. And what do I mean abuse it? I mean you come into this class and you say, man, this would insult a child. A monkey would pass. Right? This is the most casual observer can see the answer is 15 meters per second. And so then by the time you get to the first couple weeks in the class, you still have bad study habits. And you think I got it made. The thing is, what's easy to forget is that you spent a year pounding that material into your head in high school. It was hard, and you learned about a third of this class, or maybe a half of this class material in a year's worth of time in an earlier stage of your life. And you've forgotten the pain. It's like childbirth, I guess. But you remember the results. You know how to do physics. It's comfortable for you, right? And then you go through. And I never had a child. I have no idea. But after my wife tells me, and you forget. After the first midterm, you sail through the first midterm, easy. So at that stage in the class, your entire week is scheduled to the millisecond, right? With Glee Club and the chess club and whatever you guys do. And so then I don't know, football games and stuff. So then the acapella group you're in, and then up comes the second midterm, and you bomb it. And then the red light and the flags and all these things. But then it's too late. It's really hard to recover. It's worth a lot of your grade, and finals coming fast. The exams come quick in this class. So the trick is, be one of the people up here I didn't bother to mark who got AP. This guy probably got AP, or this gal here probably got AP Physics over here, right? This person, they got AP Physics too. It's just that they early in the semester should have good study habits, allocated a good solid number of hours per week to study for the class. So don't be one of the people down here. Be the person up there. Right? And you have an advantage if you take AP Physics. But you have to take advantage of it. Put it to use. All right, how are we doing? Oh, we're pretty good. Yeah, okay, so that's most of what I'm going to show in terms of the overhead. I think I got through my business. That was there's a little bit more about how to succeed. Let's see. What else I want to say about how to succeed? Let me just make you say right. First lecture, grade breakdown. Oh yeah, and so one thing I don't. In this class, I often don't give it too precise a description early on in the semester of how the grades are allocated. But the thing is, if it gives you comfort to think of this as a curved class, think of it that way. Because in fact, that's what's going to happen essentially. The distribution of grades, I've taught this class quite a few times now actually, and the distribution of grades is pretty much always the same. There are some fluctuations, it can fluctuate a little bit, but if you assume it's curved, it'll be the same outcome. One thing I always do at the beginning of the class though is I guarantee anybody, I say, look, if you get 90% or higher on the cumulative core score based on that breakdown you saw for the final and midterms and the homeworks and the labs and all that stuff, I guarantee you'll get an A in the class. So if I mess up and if I think my exam's too easy, right, or we grade them too easily, right, we do holistic grading in the class, lots of partial credit. If you get too much partial credit, everybody, it's a logical possibility that everyone will get an A in the class. This never happens, okay? It never happens, but it also never happens everybody gets an F in the class, right? It always happens that there's that same old bell curve distribution. Why? Because it's a huge class and different students with different motivation levels and some of you are really motivated to do well, some of you have other interests, and that's what happens. So that's always what happens. But essentially, the thing is, what I don't want to do is this. I don't like to say in the first day of class, this class is curved. So you're in competition with the person next to you. That's not the way this class works. You will benefit your score in this class by answering questions in class. Even if someone else hears you give the answer, you'll benefit by talking to people, other students in the class when you're working on your homework or trying to learn the material. Working with groups. When you're in your sections, work with people in sections. Speak up. Make mistakes in front of the people. Have them correct you. You correct their mistakes. That's the way you learn the material. You're going to learn the material by solving problems and doing as much of it yourself as you can. But as I mentioned earlier, the way to do that is to not get stuck on one part of the problem for longer than 15 minutes before you get help or read the book or do something, right? And it's also not to just get help as soon as you have any problem and have someone tell you to solve the whole problem. Don't just have other students in the class who know more physics than you already tell you how to solve every problem and just write down their answers. It's easier that way in the beginning, but it'll come back to bite you later. You won't really learn the material that way, even if you're getting 100+% on the homework, right? You can get 100% on the homework and still not be really learning the material. So make sure that you're really struggling with the problems and really learning, getting the answers, right, yourself as much as possible, right? Learning the material, but don't spend too much time stuck, right? And the apropos for this was what? There's something else I was going to say about that. Well, probably come up again. Okay. All right, so I'm harping on these sort of general how to do well in the course. So maybe I'll talk a little more about physics and then work my way into a little material, actual discussion of science. So one thing I like to distinguish in the class, physics is different. So physics is a science, study of the natural world, properties of the natural universe, right? Not just the world, universe. It's not really engineering. Engineering is about building devices that take advantage of the laws of the world to build useful things. And so I like to say that in the class. This is really a science class. It's about understanding the laws of the world, not about building things. But of course, they're intimately related. So there's a relationship there. But I always mention that because when I talk to people who who've been out of college for a while or never took physics, they don't really appreciate the difference between science and engineering. That's really our goal. We're trying to train you about the laws of the world. Okay. Well, let me tell you one more thing about how to succeed. So I got an email from a student a couple semesters ago. Said, Professor DeWeese, an anonymous email from Yahoo. I'm a student, he gets witness protection or something. And he says, oh, I'm taking your class, and the whole class agrees with me. I polled 30 students in the class, they all had exactly my experience. And that's 10% of the class, so okay, I hand it to him, or her, I don't know, I'll say him for the sake of argument. And so he says, yeah, so here's my experience. I read the reading you said before lecture, I came to your lecture, everything you said I followed, all the things I took notes, I followed what you said, and then I sat down to try to do the homework, I couldn't get started on the first homework problem. You're clearly not doing your job. You're not telling me in lecture what we need to know. You're not telling us what we need to know to be able to do the problems. And so I wrote him back to thanks for your email. I'm sorry that you felt you had to be anonymous. That's the only thing that makes me mad about your email. You didn't tell me who you were, because not because I'm not going to retaliate. I would never retaliate. You can always tell me stuff in office hours or email or whatever else if you're legitimate. This is a legitimate concern, right? You can tell me. So the thing I said next was, look, your experience is typical, it's normal, even for physics majors. You read the book, it makes perfect sense. You know, when you're just reading the book, it can make perfect sense to you, and yet it doesn't mean that you can just sit down and do the homework, right? And then you come and you watch lecture, and I go up there gesticulating and doing something bored. And then you sit down trying to do the homework problems. It turns out the homework is hard. You can't solve the first part of the first problem, right? That's normal. Then what you do is the things we described earlier, right? But the student was used to other classes where usually what happens is in lecture you get the information and you put this back, or it's either written explicitly in the textbook or it's given in lecture. You respond with that on test questions and on homework, and that's all you have to worry about. And not all your classes, but some classes work that way. And this class doesn't work that way. So I wrote him back and said, yeah, it's normal for physicists too to have this experience. And he wrote me back later and said, thanks so much, because professors never respond to my email. First of all, I wonder why with these negative emails. But then the second thing is, but you should. But the second thing is that he said, no one ever told me that. No one ever explained to me what it's supposed to be like to learn the material. That's why I make a deal about it the first day of class. So I think a lot of students are surprised by it, and it takes them half the semester to realize really what they should be doing to learn the material. So anyway, that's my little anecdote. Never found out who that was, but anyway. Okay, so in this class, what kind of math are you required to know? So you better know algebra. And a lot of you don't, if you're honest with yourself. A lot of you haven't had to really, and you've learned it, but then you haven't used it much. A lot of students in this class struggle through the entire semester because they never really get comfortable just multiplying, dividing, adding, subtracting. And fractions. Fractions are, and there's plenty of very smart, well-educated people who never really learn how to be comfortable with fractions. In this class, you'll be taxed a little bit on your ability to deal with this. Now, on your homeworks, you're going to be using your calculators, most of you, right? And homework often, the math and physics homework, I'm sorry about this, but they do require a certain number of digits of precision. They'll ask for a certain number of significant figures. That will not play hardly any role at all on exams. You're not going to be required to write things out to 5 significant digit figures or whatever. You're going to often round things off to 1 significant figure. So if you just get the right order of magnitude, that's going to be most of what you're after, right? And getting I don't care about sig figs, okay? But mastering physics does, and I can't control that, so it'll be more strongly emphasized. But the result is that students use their calculators when they do their homework. But you should practice doing a little bit of multiplication and division before the exam comes up. So you don't just spend your time struggling with simple multiplication and division because you're rusty, when really you should be showing off your physics knowledge, right? So we're not trying in this class to test you on your math skills per se, but it turns out to be a little bit of the class. Not as much as the 7 series, but it's a little bit of what you have to know. So you have to know algebra. You have to know vectors. And we'll talk about, mostly in this class it'll be, like, we're never going to really have to deal with 3 dimensions, but you're going to have to do a little bit of 2-dimensional vectors, right? You'll have some 2-dimensional space, you'll have some vector. Sometimes we'll have things in space that have a vector. Maybe there's a velocity vector pointing in some particular direction. And I'm getting ahead of myself. I'm starting to draw crazy pictures of stuff. But I've got some velocity pointing in some direction. Maybe the thing we're talking about is a ball in this particular position in space, and x and y are positions in space. I'm mixing up velocity here with positions. We'll do all kinds of things in this class that are not, which you don't see in your calculus class. Everybody here has nobody here not had calculus. Everybody said calculus. There's often in this class 1 or 2 people who have not had calculus. They have to hustle to catch up. They can still do it though if they can learn the very rudimentary part of calculus. What you're not going to be tested on in this class is you're not going to get some integral on the final exam that requires you to do integration by parts followed by some trigonometric. That's not going to happen. You're going to have integrals maybe, but they'll be so simple you won't even think of them as integrals. There'll be so what's the circumference of a circle? 2 pi r, right? So you did an integral, but that's the answer, right? So that's the kind of integral you have to worry about in this class. On the homework, occasionally there'll be an actual integral. You'll have to integrate, x to the third, or dx, right? And say, what is the integral of x to the third? I almost said 1/3 x to the fifth, right? I think that's correct. And there's a constant integration and whatever, right? And whatever, a to b, okay, so it's, okay. So jog your memory, remind yourself to do this stuff, but you're not going to be tested on integration per se. It'll show up on a few homework problems. But you'll have to understand what integrals mean to make sense of the physics equations. You have to understand what it means, right? And you have to understand, especially if you take AB later on, there's a lot more of that in AB. It's inescapable. We're going to keep it pretty much 2-dimensional in this class, usually 1-dimensional. Most problems, a lot of what you do when you're solving a physics problem is find ways to make it simple, make it easy. You'll be given a problem in 3 dimensions, you have to reduce it to 2 dimensions, and then reduce that to 1 dimension. And you can usually do that in this class. And that's a lot of what you're learning how to do, set the problem up. So yeah, trigonometric, you better know your sines and your cosines, right? Right, sines and cosines. You should know those things. And of course, there's other things too. There's tangent, just sine or cosine, right? And then there's hyperbolic. Yeah, we talked about hyperbolic functions. But you should know what an exponential is, right? You should know about exponentials. Their own derivative, right? These have nice properties. They show up in physics all the time, right? They show up in biology all the time too, for similar reasons. That there's a lot of differential equations describing phenomena, and differential equations involve, you guessed it, derivatives. And you have a function that equals its own derivative, or equals minus its own derivative, or equals its own second derivative, things like that. You tend to get functions like exponentials, sines and cosines, and things like that. So they show up a lot. Yeah, calculus, I mentioned that, right? Not tested on integrals per se. Let's see, right. And the way I'll try to do the lecture, so the way it works in the lecture, so far, as you can see, like in my lectures, I'll often cover stuff that's extremely rudimentary. I try in every lecture to have some really basic, basement level stuff, entry level stuff. But I also try to have a few things in the lecture that are there for the more advanced students. Today will be a little bit of an exception because today's really intro, like mostly about business and a little bit of just general stuff like this. So today's unusual, but starting next lecture, I'm going to try to mix it up. I'm going to try to have some things in the lecture that would be a surprise or a stumper for everybody in the lecture hall.